Bismillahirrahmanirrahim. Assalamu alaikum. Welcome back to the series on some important theorems and their corollaries from calculus. So let's discuss now a simple corollary, or you may say that you can call this as a theorem as well, but that's an important result based on intermediate value theorem. So what is the result? So I can call it a corollary. So it says that if f of x is continuous on a to b closed interval and f of a and f of b differ in sign, then we can find a zero of f of x in the interval a to b. So it says that if f is continuous and f of a is positive and f of b is negative, or f of a is negative and f of b is positive, so one of these condition holds. F of a should be positive with f of b negative, or f of a should be negative with f of b positive. If one of these conditions holds along with continuity, then we can find a number x in the interval a to b such that f of x is equal to 0. So you can find the root of equation given by f of x, or you can find the 0 of this function. Why does this result hold? It simply holds because if f of a is positive and f of b is negative, then 0 can be taken as k. If you haven't seen intermediate value theorem, must see in the previous value. So you can take this value k to be 0, which is between f of a and f of b. So I must find c such that f of c is 0. If I elaborate this graphically, so it says that if you have got a function for which f of a is let's say positive somewhere here, and f of b is negative, let's say somewhere here. So if f of a is positive, so this is my f of a, let's say here I have a and here I have b, this is f of b and this is f of a, so this is f of b. So 0 is here, for this 0 I can find c in this interval. Or in other words, you can see that if f of a is positive and f of b is negative, so the graph must intersect this x-axis, and hence you have a 0. Our graph might look like this: f of a negative and f of b positive. So for that case, if f of a is negative here and f of b is positive here, so let's say this is f of a and this is f of b, then you can again see that the graph must be intersecting this x-axis. So this is f of a, this is f of b, 0 is here. So by intermediate value theorem, you can always find a value between a to b such that f of c is 0, a value c in the interval a to b such that f of c is 0. Let's implement this idea. So I'll consider a function f of x equal to x cube plus 2x minus 1. I want to see whether there is a root of this equation, or whether there is a 0 of this function on the interval. What interval? I'm giving the interval on this interval. I want to see whether there is a 0 of this function. So if there is a 0 of this function, then I have root of this equation. So I'll see just that, I'll just verify that I have a 0 for this function. I'll show that I have a 0 for this function on this interval. So I'll calculate f of a, which is f of 0, which is 0 cube plus 2 times 0 minus 1, which is minus 1, f of 1, or f of b, which is 1 cube plus 2 times 1 minus 1, which is 2. So you can see that f of 0 is negative and f of 1 is positive. So we must have a value. You can call that value c, or you can call that value x. We must have a value x in the interval 0 to 1 such that f of x is 0. So you had a function, so you just have showed that you have a 0 of that function on this interval. When you have a 0 of this function, that means this is equal to 0 on this interval, somewhere on this interval. That means there is root for this equation. So intermediate value theorem is helping you to guarantee the root of a particular polynomial or any equation on a given interval. I'm given with another function f of x equal to x square minus 2 minus cos x, and I want to see whether there is a root of this equation on this interval or not. In other words, I want to see whether there is a 0 of this function on this interval or not. So I'll simply apply the result that we have recently seen. So let's compute f of 0. So f of 0 is going to be 0 square minus 2 minus cos of 0. So you all know that cos of 0 is 1, so this is minus 3. Now let's compute f of pi. So f of pi is equal to pi square minus 2 minus cos of pi. So you can see that this is pi square minus 2 plus 1. This is greater than 0. This is positive quantity and this is negative. Because f of a is negative and f of b is positive, so there exists x in the interval 0 to pi, or I can find x on the interval 0 to pi such that f of x is equal to 0, or you can say that x square minus 2 minus cos x is equal to 0, or you can say that this equation has a root on this interval. So you can see many interesting other applications of this intermediate value theorem. In the next video I'll show one more interesting realization from this intermediate value theorem.